So in this video, we are continuing our discussion on factoring. Here in these examples, we have the cubic factoring and the factoring by grouping procedure. Now for cubic factoring, we'll always have perfect cubes. When we have perfect cubes, that's how we can break down their factors further. In this situation, we have the quantity x cubed minus a cubed, or x cubed plus a cubed, which are perfect quantities of one another. Now in this problem, we must factor out x cubed minus 8. The first factor you see here is x minus 2. This is a linear one-dimensional factor. Now to get x minus 2, the cube root of x cubed is x. The cube root of negative 8 is negative 2. Negative 2 to the third is negative 8. X cubed is x cubed. X to the third is x cubed. You must take the cube root individually of the x cubed and negative 8 to get the linear factor x minus 2. Now for the second quantity, x squared plus 2x plus 4, x must be squared, which comes from the linear term x minus 2. X is squared to give you x to the squared power. Now for positive 2x, you must remember that you multiply negative 2 times x from your linear factor, then you get a negative 2x. But you must switch the negative sign, multiplying it by negative 1 or flipping the sign to get a positive 2x in the middle term. The last term is actually parentheses negative 2 squared. That negative 2 squared becomes a positive 4, which is our very last term in this quadratic. So our solution to this is x minus 2 parentheses x squared plus 2x plus 4. Now, you can verify these two factors by foiling x times the quadratic quantity and plus negative 2 times the quadratic quantity. Now, the quadratic quantity x squared plus 2x plus 4 can't be factored out further unless you try it to use the quadratic formula or complete the square method, which is not illustrated in this video. Now here we have the next method called factoring by grouping. Now we must factor completely this problem, denoting a, theta, x, c, b, and quotient as independent parameters of one another. Now we have this problem, see, a theta x z plus a q x plus b theta z plus b quotient. The first two terms, let's try to factor them directly out, since it's the simplest way to factor out the problem. And factor out the last two terms. Same procedure as first. When you break them down, you have a GCF for the left two terms being 8x parentheses theta z plus quotient. And for the second last two terms, your GCF is b. Inside you have, well, looky here, you have the exact same factor in that parentheses, theta z plus quotient. When you have these like terms, this is what will happen in the next step. You end up with the linear factor ax plus b times theta z plus quotient. Since ax plus b, provided in the previous step, share same factors inside their parentheses, we have to end up forming up a parentheses for ax plus b as a quantity written in parentheses. So ax plus b is a factor plus theta z plus the quotient. Now when we do that, this is our final answer from this original problem. ax plus b times theta z plus quotient. This is our solution for factoring by the grouping method. Now, if I didn't make myself clear, to do factoring by grouping, if you have two terms which you can see that they share so many greatest common factors in common, the first two terms and the last two terms individually share the same two terms in common, if you can factor them out by parentheses, and you end up with the same two factors for the first two terms and the second two terms in the parentheses, then you can group them out like this. I hope these examples helped you solve cubic factoring problems and factoring involving grouping. Take care, everyone. Hope you learned something from all these examples provided here in this video. Keep practicing. Enjoy. Cheers.